A ball swings freely back and forth in an arc from point 1 to point 4 as shown in this picture here. Point 2 is the lowest point in the path, point 3 is located half a meter above point 2, and point 4 is 1 meter above point 2. Air resistance is negligible. If the potential energy is 0 at point 2, it's the base of the swing, where will the kinetic and potential energies of the ball be equal? What is the speed of the ball at point 2? So this is a simple pendulum, and since there are no other forces acting on it, its potential energy and kinetic energy will always add up to the same value. So over here, at the top of its swing, like points 1 and 4, it will have its maximum possible potential energy. And at point 2, or the base of the swing, it will have the maximum kinetic energy and the least potential energy. So it's asking, where will the kinetic and potential energies of the ball be equal? So we know that the potential energy is given by the mass times the gravity times the height. And when they're equal, half of that potential energy should be converted to kinetic energy so that they're equal. So when it's at the top of its swing, the potential energy is mass times gravity times 1. And then when it's at point 3, you'll notice that the potential energy gets halved. It's 1/2 of this value over here. So that is 1/2 of that value. So at point 3, half of its potential energy will be converted to kinetic energy. So the answer to the first part of the question, where the kinetic energies and potential energies are equal, is going to be point 3. So write that down. Point 3. So now that's the first part. Now the second part is asking for the actual speed of the ball at point 2. Now point 2 is the bottom of the swing. So all of the potential energy from point 4 will be converted into kinetic energy. So we can just simply write that the potential energy is equal to the kinetic energy at point 2. So we know that the potential energy is simply the mass times the gravity times the height. I'm going to set that equal to 1/2 times the mass times the velocity at 2 squared. Remember, kinetic energy is 1/2 times the mass times the velocity squared. And now we can just solve this for the velocity at point 2. You can multiply both sides, the masses cancel out. And then you can replace h with 1. So then you'll just get 2g is equal to velocity at point 2 squared. So the velocity at point 2 is equal to the square root of 2 times the acceleration due to gravity. And again, the height cancels out because it's worth 1, and anything multiplied by 1 is still itself. So if you solve this, then you'll get that the velocity at point 2 is about 4.4 meters per second. And that is the solution to the second part of the problem. And this is how you would solve this problem.